Hi everyone, welcome to my YouTube channel. Today I'm going to walk you through one of the Kaggle competitions that I did last week, and that was about insurance cross selling. So, let me walk you through the steps, like what I basically did to get to the analysis and then finally implement the machine learning and then getting the predictions. I've used the XGBoost. We will also look at the machine learning algorithm and why I used the XGBoost. So, without any further ado, let us get into the workbook. All right, so we are in our workbook. First and foremost, I have loaded the data NumPy, Pandas, Matplotlib, Seaborn. I've also imported the warnings and the XGBoost. First, I'm loading the data. These are the three data sets that have been provided: submission, test data frame, train data frame. And then I have done the exploratory data analysis steps. So first I'm exploring the head of the training data set. So as we can see, we have ID, gender, age, driving license, region code, vehicle age, vehicle damage, annual premium, policy sales channel, vintage, and response. So this is our main variable which we need to predict. And it feels like there are not many columns, and data looks clean as well. Now let us look at the test data frame. The test data frame is also having similar columns, but notice that response is not here. Response is something that we would need to predict in the test data. Because this is customer data, hence I am checking whether any line item is duplicate for a customer or not. In case if it would have been duplicated or customer is a duplicate customer, then we would need to treat that. But here, our life is easy. We don't need to do anything. The data set looks clean. Next, if you notice in this data set, ID is a nominal data, just like a name, and it would not be useful in the analysis. Hence, we are dropping the ID column. Then we are checking for null values. If we have null values, then we would need to treat the missing value. But in this case, neither the training data set or the test data set is having any null value. Now let us look at the shape of the data set. When you look at the shape of the data set, it looks like the data set is really, really huge. And once the data set is huge, it would take a lot of processing and computational power, and the algorithm can be very slow. Let us check the info and see how each of the columns are stored in which kind of data type. For example, we see gender is stored as an object data type, age is stored as integer 64, vehicle age object. So we got a sense that, okay, these are some of the data types in which they are stored. Generally, what we see, and when we study data types, we know that object is one of the data types which can accept anything, numerical, spaces, anything. And that is the reason the object data type takes the maximum space. And categorical features like gender, vehicle damage, yes and no, these should not be stored as an object. So if we treat these as categorical, the size will considerably reduce. So similarly, integer 64, integer 65 is taking more space than integer 8 or integer 16. And when we are working with large data sets, it will make a lot of difference. So what I have done is I have created a function because I need to treat my training data also and also apply the same steps on the test data also. So here is a function where we are optimizing data types. These are the object columns, these are integer columns, and these are float columns. And the beauty of this function is that the machine, it will automatically decide whether in float it has to do a float of 16, 32, 64. That I don't need to take care of. I'm just mentioning in this function that convert it into proper integer, proper float. After applying this function to the train data, let us look at the information again. And this is the memory usage. It is 252 MB. What was previously? It is 965.5 MB. So how much of a reduction? It's almost like 4 times, 3.5 and 4 times reduction in memory. And this will increase our speed and efficiency of the machine learning process. Similarly, we optimize and treat the data for the test data set. After we have treated the data set, now let us do some more exploratory data analysis where we are trying to understand the categorical variables and the numerical variables separately. We do them separately because uh, we have different kind of plots for categorical and different kind of plots for numerical. For categorical, we usually do bar plots, stacked bar chart, and for numerical, we mostly do box plots. Now, let me quickly explain what are the observations when we analyze categorical columns. So first what I have done is I'm trying to understand the count of values in each of the unique values in that particular column. So for example, gender, male, this is the count, female, this is the count. So just glancing at it, it tells me that there is a balanced values for male and female. Similarly, for driving license, 1 and 0, 1 might signify 1 signifies a driving license, and 0 signifies that the driving license is not there. So there's a huge skew in the data towards people who have driving license. Previously insured, what is the count? Okay, balanced. Vehicle age 1 to 2, less than 1, greater than 2, less greater than 2 years vehicle age, the count is less. Vehicle damage, yes and no. This is also pretty balanced count. Sometimes count might not be giving us the exact picture and we would want the percentages. So this is again to see what's the male percentage, what's the female percentage. Another way to look at the data. All right, plots. Plots is also one of the ways to look at the data. Here for male and female, we can see that this the blue bar indicates that they did not respond favorably to the insurance calling, and the orange bar denotes that they uh, those are the individuals who responded favorably to the insurance calling. Looking at it, we find that okay, males have responded to a greater extent on the insurance calling. People who have driving license, people who are not previously insured, vehicle age is 1 to 2 years, and if the damage vehicle is a yes. These are some of the areas where we are seeing a higher frequency. So this is just to get a sense of the data, like how the data frequency distribution is there. I've also done a percentage wise analysis that for male and female, what are the percentages for a response, no and yes for the insurance calling. And we can also draw some percentage metrics from here, and you can see the observations that I have mentioned based on the table above. And you can read that from my Kaggle notebook. All right, now let us move to the analysis for numerical columns. So, first and foremost, box plots. Box plots give us an idea of how the data is distributed overall. It helps us understand, are there any outliers or what is the range of distribution. So, for example, age is mostly falling between 25 to 50 with a median age of say 38. Region code does not make sense here. Annual premium, you can see so many outliers, right? Most of the premiums are in this range, but then there are so many outliers. So this tells us that we would definitely need to scale the data, uh, especially for machine learning algorithms. We need to scale the data. Policy sales channel does not make sense here. Vintage, this is the range for vintage. Now let us plot. I've plotted this same box plot with a hue. I've added this hue just to differentiate what is the distribution for po- a positive response for insurance and a negative response for insurance. This is just to see that if there is a huge difference in the median values of those numerical columns. And this is interesting, right? You see, for age, the median value of the age for the response category 1 or the people who responded positively to the insurance, they are higher in age. They are older. What's the median age for 0? It's like 32. And people who have responded favorably, their median age is around 43. So that is good to know. For rest of them, we do not see much of a difference. We do see policy sales channel, the median value is different, but I would not take it into the interpretation because I think policy sales channel, though numerical, is categorical. All right. Now, as we have done some exploratory analysis, we are ready to prepare the data for machine learning. So, first and foremost, when you looked at the data set, there are a lot of categorical columns, right? They are in categories. So, these categorical columns, like male, female, they have to be converted into binary numerical format so that the machine learning can understand that data. Quickly, I'm using the PD dummies to do the one hot encoding. And after I apply this one hot encoding, I can see that mm, the categorical columns are all now converted into dummies and they are into numerical format. So, for example, gender is no longer male and female, it's only gender male. 1 means male and 0 means female. Then I've computed the correlation matrix here, and these are the correlations that we get. I couldn't get much of the insight from the correlations, even though some of the correlations are high. But it looks like most of these features are categorical variables. So these metrics are not making much intuitive sense so that I can drop one column. So the whole purpose of creating a correlation matrix is trying to find high correlated variables and dropping one of them and giving the machine learning the proper set of variables. But here I could not find, and I've written these observations here so you can read them in my workbook. Okay, now we find that the data set is good and we can split the data. So I have split the data here into X and Y. I have scaled the data because the data had outliers. Now I'm importing the XGBoost. I've used the XGBoost because it's a very, very powerful and efficient machine learning algorithm, very well known in and very well it's highly used in competitions like Kaggle. It can treat outliers by itself, uh, get into the nuances, apply boosting, bagging techniques, and it gives very quickly the fair and accurate results, irrespective of what the data distribution looks like. So definitely, rather than experimenting it with logistic and other random forest decision tree, I've directly used the XGBoost. And then we have this splitting of data, and then I've applied this model. Here I'm using the receiver operating characteristic curve, the area under the curve, to find this curve. This is the false positive rate and true positive rate, and the area under the curve is a 0.88. It's really very good accuracy. I've also plotted the feature importance, and two of the factors play a dominant role in estimating and predicting whether the response of the insurance is yes or no. What are the two of these factors? Two of these factors are vehicle damage, yes, and whether they were previously insured. Because we have got this model and we are okay with this model, and then now we proceed to apply the similar steps on the trained data set. I'm using the PD get dummies here. I'm using the standard scaler again here for the test data set. And then based on the model that we created, I'm using the predict probability function to predict the response variable for the testing data set. This is the prediction data set. And now I'm looking at the submission data set that was provided. And I'm creating a data frame where I am just adding response to the ID variable. And then I'm submitting it. So once I have submitted it, I have got a very decent accuracy. And let me get you to the starting page where I can see that the score is about, my result is about 85% accurate. Okay, so that was the walkthrough on the insurance cross selling parallel competition. Hope you found it interesting and learned something new. And I will see you in my next video. Thank you for watching.